Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will see how to perform a zero downtime migration using Oracle Golden Gate. So I have a business case in which there is a mission critical database which cannot afford to go for the downtime, and we have to migrate the database which is residing on 11.204 to 12c release 1. And we are going to use the Oracle Golden Gate just to make sure that we achieve the zero downtime migration. In this setup, what we are going to use is we have two virtual machines, VM1, VM3. The IP address of virtual machine 1 is 192.168.1.51, which is having the Linux operating system, and the database name is source, and database version is 11.2. The target where we are going to migrate the particular schema. We are not going to migrate the entire database. It is just a schema. So more or less the procedure would nearly be remain same, because we are concentrating more on Oracle Golden Gate and the instantiation of the source schema to the target schema. So my target environment is VM3. The host name is Linux 3. IP address is 1.71. Database name is target, and database version is 12.1. Oracle Golden Gate binary is already installed on source and the target environment. On source, the database, the Oracle Golden Gate version is 12.1. On the target, it is 12.3. During the execution of this demo, we will be creating some parameter file onto the source, which is manager extract. The primary extract is ext1, the secondary extract, which is your pump, which will be pmp1, and the tables which will be replicated during this course will be source test table underscore 1, 2, 3, and 4. The schema remains on source is source test user. On the target, we are going to replicate it with the same name. The Oracle Golden Gate is already installed. It is on Linux 64-bit. User which we are going to use is Oracle. Manager port is 7809. The installation binary is this, which is already installed, and it is running. The manager is running on 7809. Local trail on the source will be used on this particular directory, which is it will be crs underscore home / source. On the remote, it is going to be /software / source. Prerequisite source and the target database should be up and running. All the schema should be available onto the source environment. And the first step which we are going to perform is we are going to prepare the source environment. So what we are going to do is we are going to create the environment, and the environment will be we will be turning the database into archive log mode. Then we will be turning the database into the archive log mode, and flash log. We will be enabling the flash. We will be enabling. Let me show you what all we are going to do onto the source environment. So I'm logged in as Mova Extreme onto the source and the target environment. There are 4 sessions open. So 1.51, it is my source. Let me show you the preparation of the source environment. This is source db.sh. Setup source db.sh. So if you see the script, it is just setting some stream pool size to 300 M, and then turning the database into archive log mode. Then we are enabling the supplemental logging. Then we are creating the schema source test user. Then we are granting it some permission. Then we are creating a table space, which is tbs underscore ggate. We are creating a user ggadmin. Then these are the 4 tables which will be populated from db underscore objects, just to have some data. So let me execute this script. So this is going to prepare my source environment sh and setup source db.sh. This will take its own time. In the meantime, what we will do is we will prepare the target environment as well. So the target script is similar to the source script. There is a bit difference. Let me show you this. Again, it is turning the database into archive log mode if it is your requirement, then supplemental logging, force logging, then creating the schema which will be required onto the target environment, creating a Golden Gate user and giving the required permissions. So this is what we are going to do onto the target environment as well. So let me prepare the target environment as well. This is going to take a couple of minutes. Once this is over, we will start working on to the Oracle Golden Gate executables. Okay, so once the source schema and stuffs are ready, we will enable the DDL enabling on Oracle Golden Gate so that it is going to support the Oracle Golden Gate. Let me see, where are we onto the source environment? Okay, this is perfectly fine. The error is because I have given the backslash, so it has not taken. That's fine, perfectly, we can ignore it. Onto the source environment, let's enable the dot space aura env underscore source. This will take me to Oracle Golden Gate GGSCI prompt. I'm into, yes, now log into SQL Plus as sysdba. We are going to enable the DDL application. So we have to execute all these scripts. It will prompt for what do you say, the Golden Gate schema, the Golden Gate schema name, which we have, the Golden Gate, it is ggadmin. So we have to provide that. This is my first script. Let's execute the second one. ggadmin is the Golden Gate schema name. The second one is then role setup. This is still okay. This all is going on fine. Onto the source environment. Then the third script, it is prompting for the schema name, Oracle Golden Gate schema name, which is ggadmin. Then go for the DDL enable. We are okay. This is done. Let's do DDL underscore pin. ggadmin. So wherever it is prompting, you can just fill in the Oracle Golden Gate schema name, which is ggadmin in my case. The target environment is getting ready. Okay, this is fine. That's perfectly fine. Now we are going to prepare the manager parameter onto the source environment. Let's see if it has executed or not. Please enter the name of the schema for the Oracle Golden Gate database objects. This is ggadmin. All the scripts for enabling the DDL onto the source environment is completed. Now let's create the manager parameter file onto the source. We have created this directory which is required to store the local trails, and aura env underscore source. This will take me to Golden Gate command line interface. Just say edit params mgr, and we will put these values. We're not going to discuss this because this has been discussed so many times in previous tutorials. Now let's create the subdirectories if it is already not created. This is already existing. That's fine. Let's go into the target environment and prepare the respective directory where my remote trails will be stored. Now let's log into GGSCI prompt and just say edit parameter mgr. Edit parameter mgr and put all the values. So all these values are the 3 lines: port, dynamic port list, purge old extracts. This is the demo, so we may not actually be able to delete the purge old extracts because it is not going to satisfy this condition. So, and since it is a non-default location, we will populate the .globals parameter also. Otherwise, when you start the replicate, it may not be able to. Yes, this is done. Now let's create onto the source environment. What we are going to do is we are going to create the wallet for creating the um, let's do it for the target environment first. This is creating the user ID alias, so it is done onto the uh, target environment. Let's do the same onto the source environment, and then we will add the tran data onto the source environment. This is done. Let's enable the add tran data and the schema. So all the tables under this will have the tran data enabled. Now let's create the extract onto the source environment. So we'll say added params, added params ext1. So if you see so far, we haven't done anything differently other than just a normal one-way replication. We will be coming to a point when we take an export backup. So at the end, you can see table source test table dot star. So all the tables under this will be replicated, and our local trail will be stored at this position. And this is now. Let's register it. This is done. Just say info all, just to see if it is registered properly or not. This should be visible. Yes, ext1 is there. Now let's do the same for the pump parameter file. And extract pmp1 user ID alias we have given, the remote host is this one, and remote trail will be at this location. So just enable this as well. Once it is done, just register it. This is done. Now we are going to add the checkpoint table on the target. We have already created the user ID alias onto the target environment. This is my target environment, and the checkpoint table is also created. Onto the target environment, let's create the replicate. So far we are just creating the parameter file and the processes, and at the map it is source test user dot star, and the target is also like this. So we are saying assume target def. So we are assuming the definition remains same onto the target. So there is no change in the table structure. Just register it, and the important part of registering the stuffs are done. So you can see there are two more terminals open where I have just done the tail -100f of ggс error.log. Just you can see what all you have done so far onto the ggS CI prompt. So everything will be logged over here. The next step onto the source environment is what we have to do is we have to start the processes onto the source environment. Let's start the manager, start extract ext1, then you start pump process. Pump process will fail because onto the target environment the manager process is down, so that is fine. We can start it later, or you can start the manager process. It will go down. Info all. Yeah, this will go down any moment. The pump process, yes. You can see the error 111 connection refused. Now what we have to do, this is the most important part of this zero downtime migration, because we are going to take a schema backup up to the source environment, and whatever changes are happening after this backup, they have to be replicated to the target environment. So what we have to do to achieve this, we have to find out the current SCN of my source database environment so that we can track it using that particular SCN. If you are not going to do, then we are not going to achieve this. So this step is very, very important. We have to find the current SCN of to the source environment. This is what is there. So I have expdb.sh is already available. I have created it in advance. So there is a parameter along which says you have to put flashback underscore SCN, which is equal to the current SCN of the database, so that whatever export backup or expdb backup you have taken, it will be at a particular SCN of the database, which is known as the current SCN. So when you start your replicate, you have to start your replicate after this. So any changes which have happened after this, they will be extracted and replicated to your extraction has already started. So it may be possible that it would have extracted the data of this particular SCN and after that as well. So when you start your replicate, you have to start your replicate beyond this. So it is just a simple expdb command. This is the schema and the password name, then flashback SCN and directory and all the tables I have mentioned over here. You can just mention your schema as well, so that will be fine. But I have 4 tables, so I'm just using that because I have used table level export earlier, so it is same. But it's good to have schemas equal to and the schema name. Then at the end there is a scp command which is going to scp the dump file to the target environment. So I'm going to execute it. Once it is executed and copy to the target environment, we have to import it over there. The import script is already copied to the target environment. Once it is done, we will initiate the impdb.sh onto the target environment. It is just a basic shell script having the expdb and scp commands together bound up. So this is not going to take more time. It may be done within less than 1 minute. It has started. So once it is done expdb, we are going to import, and then we will verify the number of rows. It will be remaining same because it's just an export and import. It's going on. Yeah, it has completed successfully. It has prompted for the password. I have fed in the password. It is transferring. It is transferred. The next step is impdb.sh. It is already, the script already exists onto the target environment. I need to exit out of this. I'll say cd and I'll show you what is there in impdb.sh. It is just the dump name and the location. That's it. Nothing very fancy in this, just the basic impdb script. I'll execute it. So the unique thing which we have done is we have used flashback underscore SCN just to capture the SCN of the database for the tables which are getting replicated from source to the target environment. And that is going to be important. So because if you just take an export and import, and if you don't mark like when do I need to start the replicate at what particular point, so that is the SCN number. We have to make sure that the particular SCN number is captured, and you need to tell the expdbs this is the SCN number which you have to mark, and when I start the replicate I will be starting after this. This is copied, and if you see this is some 49,660 rows in all these 4 tables, source test table underscore 1 2 3 and 4. This is my target environment, and onto the source environment you can see. So no need to cross check, it is same. Now what we are going to do is we are going to start the replicate after that particular SCN. So let me see the source environment. Info all. Let's start the MGR. MGR is started. And what we are going to do is just see this, the status. As appended, let's start extract PMP1. Info all. Okay, you can see the number has decreased from 7 minutes 54 seconds to 00. So my pump process is running fine. Now let's go to the target environment, and the important thing will be starting the replicate beyond a particular SCN. So that SCN we need to capture, we already captured in some script, and this is the SCN number. So we have to start the replicate. So we have to tell replicate you start your applying the changes after this particular SCN on to the target environment. So we'll say start replicate REP1 after CSN. This is not SCN. So just we'll go to ggserror.log file to see if there are any errors. You can see it is moving up and restoring current schema for EDL operations to ggadmin. So this should be fine. Under the source environment, there is no error. Target ggserror.log, it is fine. If you see the previous error, one of the error was because there was no connection between source and the target because the manager was down. Okay, so if we see all the processes are up and running, and lag at checkpoint and time since checkpoint, they are closer to 0, we are good. Yes, everything seems good. What we are going to do now is we are going to test. We are going to let's count the number of rows onto the source and the target environment. Although we haven't done any new insert or updates, it is just an expdp, but since we are going to perform a test, so we need to capture this. Select count star source test user dot source test table underscore 1234. This is my source environment. If you see 49,660 for all the 4 tables, and similarly for the target environment also it remains same. The test which we are going to do is we are going to insert some rows onto the source environment, and we have to make sure that it is replicated onto the target environment. Let's check. If you see onto the target environment, wildcard map resolved, so you can see some messages onto the target environment, and we can verify it using the ggsci command prompt as well. So if it is moving, that means there is something happening. Yeah, you can see there is some mapping happening for source test table underscore 2, source test table underscore 1, 2, 3, and 4. That means there is something happening, and you can verify using the stats command. So I'll just say stats extract ext1, then I can check it for the pump parameter onto the source environment, PMP1, then I can check for the replicate as well. Let's check it for the extract parameter file. 1000 rows were inserted, so you can see for table number 4 they have recorded, for 3 also recorded, 2 also recorded, 1 also recorded. Let's try the same for pump, whether it is going to put it the first, when it is going to extract, it is going to put it into the local trails. When it is going to be caught by pump, it is going to push it to the remote trails onto the target environment. So it's going to push it. When we check it for the replicate environment, that means it is going to apply onto the target environment. So we are just going to make sure that all the steps are being taken care. Yes, you can see the 1000 rows. So 1000 rows inserted. Let's verify the number of rows into the source and the target environment. Though we already checked it using stats command, but let's do it once again using the SQL prompt just to count the number of rows. So yes, you can see 50,660 onto the source environment for all the 4 tables, and the same is for the 4 tables on the target environment. So if you see, it is an out of place upgrade. My source environment is 11 release 2. This is my source environment, which is 11.204. Target environment is 12.1. If you see, we took an EXPDP backup based on the SCN of the database, and we put it into the EXPDP using flashback_SCN. That particular schema objects were exported and they were imported into the target environment. And before doing that, we have started all the extracts and pump process onto the source and onto the target environment. The replicate was started using CSN. We mentioned that start parameter start replicate rep1 using CSN. So using that, it was able to track from where it has to start the replicate from the trail file. So based on that, it has started. So this is going to be very important. So what we have done is we have migrated the schema from source to the target environment, and my application is still connected to the source environment, which is on 192.168.1.51, and the continuous changes are getting replicated to the target environment. So we did a testing. We inserted 1000 rows in all the 4 tables, and they got replicated to the target environment. So if you see, this replication is continuously happening from the source environment to the target environment. And when you are ready to cut over, when we have make sure, this is just a part of the replication, this is not all. If any, so the best way will be when you are about to cut over, when the cutover is going to happen, when you are going to make the connection to the new environment, which is 192.168.1.71. So what you are going to do is the application which is going to interface to 1.51, you are going to shut it down. You have to make sure that the extract is working properly. It has taken all the extraction from the redos of source redos of the source environment, and they are actually replicated to the target environment. Once you are 100% sure that data is completely replicated, you are good to stop the application. The first is you have to stop the application, then you have to make sure extract pump process extraction has got completed, pump process has moved all the data from source to the target environment, and replicate has applied all the changes. Once it is done, then you are good to stop the processes onto the source environment. The application is already stopped, and you are good to redirect your application to the target environment. So when we say zero migration, it is actually not zero. It is the minimum minimum downtime which is incurred. The minimum downtime is when you are switching the application from source to the target environment, because we have already done the efforts of migrating the data using EXPDP. There are several other ways of instantiating your target environment. Once you are done, you have to start your continuous change capture process from source to the target environment, and during the day of the cutover or the time of the cutover, you have to switch the application from to the source to the target environment. So the downtime incurred is just switching the application from source to the target environment, and you have to make sure that all the objects are 100% replicated. So one of the few things which we need to take care when we are doing all this is we have to make sure that DDL changes have to be taken care, so that minimum DDL changes, if it is possible. If it is not possible, then you have to check other ways, like whatever changes are happening DDL way. I mean, you have to take no rows schema backup, then you have to import it onto the target environment so that you don't miss any of the objects. And but the table space creation, data file creation onto the source environment, let's try to make it minimum, so that or you try to make sure that whatever changes happen, if it is not getting replicated properly. So one of the safest way is you keep on taking the, before the actual cutover, you take an no row export of the schema objects and you import onto the target environments, just in order just to make sure that none of the objects are missed onto the target environment. So this is just a demo wherein we have migrated one of the smallest schema. We have enabled the DDL replication on the source, and the same has been replicated on the target environment. There are several ways of instantiation. You can choose any one of them based on your environment, what is the size of the data database, and what is the flexibility of getting the data replicated from source to the target environment. But zero downtime migration is very useful when there is a mission critical database, and it may take many days. It is not a one-time activity. You take an export. If it is a very big database, let's say there are thousands of schemas which are getting which are onto the source environment, you have to make sure that you make n number of extract and pump process onto the source environment, and the same should get replicated to the target environment. This was just a demo wherein we tried to show the minimum things, but there are a lot more than this. I hope this is going to be helpful. Thanks, and thanks for watching.